So, here's the Commodore 64. Oh, wait a minute. I think I already did this video. We are actually meaning to take a look at that guy right there. What is this box? Well, it's got the Commodore logo. I'm wondering what that could be. Could it maybe be a floppy disk drive? Check that out, a floppy disk drive. Now, once upon a time, way back in the day, I can remember having to play through a part of a video game. Oh, man. I got a prompt to flip the disc. Boom. There's the disc. Poof. What? Why would that happen? Well, these things only stored 170 kilobytes of data per side on the Commodore 64. It is a floppy media, as you can see. This one's old, beat up, doesn't really have anything on it because, well, the disc is bad and it's been thrown around like a frisbee so much. But, yeah, so they were such low density, larger video games actually had to come on multiple floppies or use two different sides of the floppies. These things used a type of coding called GCR, which was a predecessor to MFM. Yeah, we'll get into maybe some of the theory and specifics of that later. Here's our toggle to lock the disk in drive and let the machine know that there's something there. There's our green power light and a red busy light. Let's go ahead and take a peek at the back. We have a couple of Commodore serial ports, one for going to the Commodore 64 and one for going to another peripheral. We have a proper IEC power connector, a big clunking power switch, and if I can get this open right, a glass fuse for her protection. We like fuses. They're nice. They keep things safe. Now, this 1541 floppy disk drive cost, when it came out, about $900, which was actually more than the Commodore 64 itself. Now, this particular unit has a 6502 CPU, 2 kilobytes of RAM, 16 kilobytes of ROM, and as I already stated, 170 kilobytes of storage space. That's amazing. Yeah, amazingly antiquated. Underneath this shield, which is designed to keep all the RF noise inside of the unit, is all of the important bits. Now, I've already pulled all the screws, obviously, from the top of the shell and from the board, so we can get some nice detailed views later. But for the moment, let's take a little peek at this board down here. That particular board does nothing more than control the speed of a couple of motors. When you close that toggle, you can see this thing, which carries the head, move up and down. We'll take a look at the head later. I don't know if you can tell what that component is right there, but that component, believe it or not, is an LED. Underneath is a small matching sensor, probably a light-dependent resistor or some other such thing, and it lines up with that slot right there, or that notch, whatever you'd like to call it. The purpose is copy protection. Keeps you from overwriting your disk by accident. If that little light sensor doesn't get seen or is seen, it changes a state somewhere in the machine. In the magic voodoo of the hoodoo of the ROM chips, it does the magic to make sure everything's happening right. Right here is that power supply line that goes to your power indicator LED. We have those two serial ports. We have AC power coming up from that IEC power switch. Actually, it comes through a transformer. We'll take a quick peek at that. So if we pull that little connector out, we'll flip that board over. Poof! Look at that big, old, beefy, heavy transformer. We'll go over some theory of inductors and transformers later, but power comes in through this connector, goes over to this big clunking power switch, goes over to the fuse, and then poof, to the rest of the system for safety. Got to keep everything, nice and non-shocking for customers. Now, if we close that, we have the head movement right here. Let's go ahead and unlock that. Right there, we have the track reader. There's nothing on top, just on the bottom. These things would get dirty, and you'd have to put in special cleaning discs which had felt on them, and put cleaning solution on them to clean them. This little motor down here is what actually controls it. This big guy right here. And this goes to the bottom of that, underneath there. And it comes up to the top of the board, right here. And that is the actual pickup head, just like in a tape deck. I don't know, maybe I should tear apart a tape deck one of these days. Now, let's go ahead and start taking a peek at all these chips and see what all these chips are doing. We have a couple of full rectifiers, full bridge rectifiers. We'll go over how that works in another video. But AC power comes in, poof, goes to there, hits these rectifiers, goes through a couple capacitors to smooth out the power, and we go to these two devices right here. These big power transistors, or actually not transistors, that's kind of what they look like though. This is actually a 7812 voltage regulator. This one is a 7805 voltage regulator. So we have two primary voltage rails. Over here, you see that bright green solder mask? That is to keep this 16 megahertz crystal from spewing radio waves all over everything and just making a massive mess. We don't like spew, that's kind of gross. So that big green thing's connected to ground, and that helps keep all the noise out. These chips here divide that 16 megahertz down to 1 megahertz, which is what all this logic runs at. The other one's simply a buffer to help distribute everything nice and cleanly. If we look right here, we have a kernel ROM chip. That's basically the operating system for this thing. This thing is basically as powerful as a Commodore 64. Has about as much peripheral capability as the Commodore 64. It had a lot of mechanical hardware over here, which accounted for a large portion of the cost. There's a lot of metal in it, which accounted for more cost, which is one of the reasons it was so darn expensive. But they were also extremely versatile. You could have an entire library of software in an inch or two of discs versus these big fat hunkin' cartridges, which, that was one piece of software right there. And this is actually a fast loader cartridge. This thing would speed this thing up by an order of magnitude or more. And, well, I'll go into that. I'll take that guy out, and we have a little circuit board. It would plug into the back of the Commodore 64, and there's a little bit of buffer logic. And this chip is basically a little ROM, and what it did was it changed the access functions, the communication between this guy and that guy, and did it in a more efficient manner. And it could transfer data very quickly. It was not exactly compatible with everything, but it was compatible enough that they were very popular. And going from 300 characters per second to 3,000 characters per second was a significant jump in performance and usability. Let's look at this chip down here. This chip is the gate array. It's a custom logic. The earlier floppy disk drives had much bigger boards with far more chips on it, and they were all these little 74 series logics. It's just glue. It has muxes in there. It routes signals different places doing different things, handles communication, invert signals. It does some voodoo and black magic to make the rest of the system work. Without it, you'd have a board this big, and then you'd have another board for just this stuff, which would be even bigger because you'd have to communicate with it as well. Anyways, so we have these two chips next. Those two chips are VIAs, the 6522, which is also in the Commodore 64. Those things have timers in them. It has serial I/O and parallel I/O, and it, well, allows you to talk to two serial devices, as well as the Commodore 64 specific side stuff, or a peripheral side thing. You could daisy chain, from what I understand, multiple of these drives, and that's one of the things that those chips are there to handle. Then we come up to the 6502. Like I said, because of this system right here, it runs at a whopping 1 megahertz. Wow, that's fast. 1 million ticks per second. Now, something that's a little interesting about the 6502, not only is it used in the Commodore 64, it's used in the Apple II. It's also used in the Atari video game system and computers, early computers, and the classic Nintendo Entertainment System, of which I had one when I was a small child, and I played many hours of classic NES games. So we've gone over the fast loader, we've gone over the floppy disk, we've gone over floppy disk flipping and switching for playing video games, we've gone over most of the logic, and we have these logic chips over here. I think I do want to go over those. They do some kind of interesting magic. The way floppy disks stored information in ones and zeros, it was actually not ones and zeros, it was a positive magnetic field or a negative magnetic field, or north and south poles. And that little pickup head that we took a little peek at earlier would read or write data, depending on what we're telling it to do, but it wouldn't give you a digital signal. It gave you kind of a sinusoidal analog waveform. And we had to do some voodoo and some black magic to make that funny squiggly line into a nice, pulse train of digital logic that the digital portion of the machine could understand and talk to. So we have a couple of comparators here, or one comparator here. This is an LM311 for those boys and girls playing along at home and like to look these up and play with them. They're very useful. Those things compare two logics or two signals, and depending on what the result is, it spits out some information. They can actually be used as op amps. Not very good ones, but in a pinch, you might be able to get away with it. These two chips over here are pretty darn interesting. They are UA592s. Those things are strangely video amplifiers. That just means they're wide bandwidth amplifiers. And those were the chips that would work in this application. Yeah. Pretty interesting stuff. We have some discrete transistors, which are probably acting as voltage followers in order to, kind of buffer these really light, weak signals before sending them to the amplifiers. And there's a lot of information about impedance matching and some other voodoo we'll get into later. Probably in another video. I have a whole list of topics I want to get into. Anyways, you all have a wonderful evening. Take it easy. Don't work too hard.